is quite similar. So you have this planar area, let's call it A, and for this one you'll have to take a differential area, be it a strip like or box like differential area, okay, and let's say this is the distance from y-axis. So the distance from y-axis is x, and the distance from x-axis is y, and I have chosen the first quadrant to show this, but the geometry could be in any quadrant or could be spanning over all the four quadrants in general. So these are the coordinates x and y of that differential area, or you can say these are the distances from the x and y axis. Then the area moment of inertia Ixx. Can you tell me how do we define that? Anyone listening? Do you hear me?
Yes, sir.
Okay. So can you make a guess that how should we write Ixx, area moment of inertia? So this is called the area moment of inertia about x-axis, and this is how it is defined. This is y squared dA. So the integrand here is y squared, and this is why this is called a second moment. In comparison, when we are trying to get let's say the x bar of a given area, this is what we would do. We would take the first moment. Okay, moment of what? Of course the differential area, but this time the coordinate is squared. Okay, so that's why this is called a second moment. Okay, so this is also no surprise that Iyy, the area moment of inertia about y-axis, would be defined something like x squared dA. Okay, and in addition, so these are the definitions, and I'm using the definition symbol. So this symbol that is the colon preceding the equal sign, that actually is the definition symbol. In addition, there is something called the polar moment of inertia. Can you make a guess what this would look like?
R square dr d theta.
Uh, yes, I mean you can define dA any which way you want. Okay, I mean you can call the differential area as r d theta dr if you wish. Okay, that doesn't matter. So you need the differential area, but what you should be taking instead is this radial distance. Okay, uh, so this r, the radial distance, and I hope this is also clear to you that this r squared is nothing but x squared plus y squared, and therefore this quantity therefore this quantity right here is the sum of Iyy and Ixx. Okay, does that make sense?
Yes, sir.
Okay, in addition there is also something called product moment of area, which is defined in this way: Ixy, which is integration over area xy dA. Okay, now this has its purpose. Okay, and if we get a chance, we'll discuss about this. And all of these quantities have purposes. Okay, it might seem off that we have started discussing geometry in place of mechanics, but yes, all of these quantities um, have their importance. Okay, so whenever you are designing, say, a robot arm which is going to carry a certain amount of load, it's the moment of inertia of the area that matters, and it's not just the moment of inertia of the cross section, it's the moment of inertia about the centroidal axis. That means instead of taking the global coordinate system, you need to be choosing the centroidal axis. So let's say this is the centroid. Okay, probably not correct, but let's say this is the centroid, and you defined a centroidal coordinate system, which is again a Cartesian coordinate system. So let's call it x prime and y prime. Okay, so those centroidal moment of inertia, okay, that actually matters. Okay, when you are talking about the load bearing capacity of a given cross section, that matters. That's why these quantities are also important when it comes to mechanics. So, and this product moment of area is also equally important, uh, particularly when you are performing coordinate transformation. What do we mean by that? That if you are representing the moment of inertia in a given coordinate system and trying to switch to a different coordinate system, you would need such quantities as Ixy. Okay. Uh, Now, in addition to discussing all of this, there is one more topic, okay, and after that we will straight away move to solving problems, okay. So the other topic is that the parallel axis theorem. Are you familiar with the term parallel axis theorem?
Yes, sir.
Okay, are you? Oh, then it's great. So, uh, okay, so the parallel axis theorem tells you that if the distance distance of the centroidal axis are respectively delta y and delta x from the global coordinate system. That means if the centroidal, sorry, um, okay, yeah, there are better ways to represent this actually. So for that, this is what we will do. Okay, so স্যার ক্লাস নিচ্ছি হ্যাঁ স্যার এই ইলেকট্রনিক্সের ওকে okay so the way we represent the centroid is using x bar and y bar. So you can imagine this, what are these x bar and y bar? This x bar and y bar are basically uh, these distances. So this distance is y bar from the x axis, and this distance is x bar from the y axis. These are the coordinates of the centroid. Okay, then the parallel axis theorem tells you that I x is I x prime plus y bar squared times a, and similarly I y equals I y prime then x bar squared times a. So these are the moments of inertia with respect to the centroidal coordinate system. So this and this, these are the moments of inertia with respect to x prime y prime or centroidal coordinate system. Okay, and these are the moments of inertia with respect to the global Cartesian coordinate system. Okay, and and we would also try to derive these expressions. So we can try one of them. Okay, so we can try getting the Ixx. So if I try to get Ixx and go by its definition, so it is supposed to be y squared dA, and y squared would be uh, y squared. So y itself should be a combination of two. So so if this much is y bar, that is the distance, that is the coordinate of the centroid. So y prime is the coordinate measured with respect to the centroid. The y coordinate measured with respect to the centroid. So if x prime is the centroidal x coordinate, y prime, the coordinate y prime is actually the distance from x prime. Okay, so now let's say for this one, this is the distance y prime, that is from the centroidal x coordinate or x prime axis. Okay, sorry, not centroidal x coordinates, it's centroidal x axis, that is x prime axis, from which you measure the distance of the differential area, okay, perpendicular to x prime. Okay, so if you do that, that tells you that y actually is the sum of y prime and y bar, and you need to get the whole squared. And if you do that, you can use a plus b whole square formula, which is very simple: y prime squared twice y prime y bar plus y bar squared d. Okay, now if I split that or expand that, okay, uh, then I'm going to get three terms actually. So the first one is integration over a area y prime square dA, that is the first term. Then you see these two terms, 2 is a constant and y bar, the location of the centroid. Okay, now y may be changing across the geometry, changing across the area, but the location of the centroid, that is actually a constant, and that is not changing if you choose a different area element. If you choose a different area element, the location of the centroid is not changing, which means these two terms, twice y bar, that comes out of the integration, and you get y prime dA. Okay, and the next term would be integration. Of course, y bar squared comes out of the integration, and then dA. Okay, now if you do all the three terms, if you do all the three terms, then we can have things to say about each of these terms. So if I look at the first term is actually I x prime x prime. As you can see, that is the moment of inertia, area moment of inertia about the x prime axis, because the uh, distance from x bar is this y prime coordinate. Okay, so this y prime coordinate, once you get that and square that and multiply with dA, you are actually getting the area moment of inertia with respect to x prime axis. Okay, so that is the first term, and then the next term will come in the end. Okay, okay, but if we go for the third term, that is just y bar squared times a. So this is what we are supposed to prove, this equation. Okay, this is what we are supposed to prove. Okay, of which we have obtained two of the terms. Okay, and then we need the third term to vanish. Okay, so for that we need to look into this expression. Okay, now this integration, okay, you already know that integration y dA over area is y bar times area. Okay, in the same logic, integration with respect to area while taking not the global y coordinate but the centroidal y coordinate and multiplying with dA. In that we are supposed to get y bar prime a. Okay, this is what we are supposed to get. Okay, now can you tell me why this quantity should be 0?
So because in this case, the origin is the centroid itself.
Yes,
So
yes, that's the correct answer. So what does y bar represent? That is the coordinate, y coordinate of the centroid. And what is the reference for measuring the coordinate? That is also the centroid. So if you are taking the centroid as a reference for getting the coordinate of the centroid, this quantity right here must be 0. And therefore y bar prime and x bar prime, both of these quantities should be 0. Okay, and if you substitute that and make this quantity to be 0, so what you would be left with is the statement that you wish to prove, that I x prime plus y bar squared times a is what equates to ixx. Okay, now please remember, this is only a coordinate transformation between two parallel coordinate systems. Okay, first of all, two parallel coordinate system, of which one of them is a centroidal coordinate system. You see, the x-axis of the global Cartesian coordinate system and the x-axis of the centroidal coordinate system, both are parallel to one another, and so are the y-axis. Okay, so these are parallel to one another. Okay, number one. Number two is the x prime y prime coordinate system has to be the centroidal coordinate system. So this is only valid, okay, when the x prime y prime coordinate system is a centroidal coordinate system. Okay, now this will tell you also something, that I x prime is the minimum value of all possible ixx. Okay, that means you can choose origin anywhere in the space. The lowest value of the area moment of inertia you would get, that is with respect to the centroid. Okay, because both of these quantities are greater than 0. So this quantity right here is greater than ix prime x prime in general. Okay, so that tells you that this quantity would be minimum when you evaluate this with respect to the centroid. Okay, such is the case with y prime as well. Okay, also I want to point out some of the other things, that these two quantities are always greater than or equal to 0. Okay, and even this quantity, these are always greater than 0, because what you are integrating is always greater than 0. Okay, so the area moment of inertia of a semicircle, okay, that actually twice the area moment of inertia of a quarter circle. Okay, so whether you are getting ixx or iyy, in either case, okay, because you are integrating either x squared or y squared, both of these quantities, okay, with respect to ixx and yyy, both would be double. Okay, when you take area moment of inertia, okay, both of these would be double. Whereas this quantity, this is a signed quantity. It means it can be greater than 0, it can be less than 0, or it can even be 0. Okay, particularly if you have a geometry, if you have, sorry, not this type of geometry, but let's say a geometry which is symmetric about the axis, okay, one of the axes, okay. Let's say this is the y-axis, and x-axis could be anywhere, okay. So for this one, ixy would be 0, because for every differential area which has a positive y, okay, will have a minus y for an equivalent differential area, okay. So if there is a dA1 over here, there is a dA2 over here, exactly equivalent to it. Whereas for both of these, the x coordinate is the same, okay. So when you substitute that the x value is the same, but the y value is 1 plus and another minus, okay, eventually this becomes 0, okay. And anytime there is an axis of symmetry, okay, so the product moment of area vanishes, okay. Now I'll not go into the much detail of the product moment of inertia, okay, but right now what we have seen is that you can perform the coordinate transformation, okay, or you can choose different axes to evaluate a moment of inertia, and you can also establish a relation between the two, okay. So whatever we have obtained here, we have actually proven that, okay. So acha, by the way, when it comes to product moment of inertia, you can also write this: I xy is I x prime y prime plus x bar y bar times a. Similarly, j is j with respect to the centroid, okay, j with respect to the centroid plus x bar squared plus y bar squared times the area. So all of this can be proved, okay, and all of you can also expect any of these derivations either in the class test or in the semester, but the proofs are no different than this one, okay. They are exactly going to be the same, so I'm not going into the further detail of that, but they are going to be same. uh, so so all of these are valid, okay, number one. Now this type of transformation, as you can see, is happening between two coordinate systems. One is xy and one is x prime and y prime, okay. Of course the x prime y prime coordinate system is a centroidal coordinate system, and xy over here we have assumed to be the global Cartesian coordinate system. But over here these two coordinate systems are parallel to one another, okay. You might also encounter a set of coordinate system which look like this. So this may be your x and y coordinate system, and this may be your x double prime and y double prime coordinate system. And if you wish to evaluate moments of inertia in this rotated coordinate system, you will need the help of this quantity, okay. So yes, this quantity has its uses, okay, but uh, we are skipping it for now, okay. So um, so we are not discussing about the utility of ixy in giving us the moments of inertia in a rotated coordinate system, okay. So up to this part, is that clear? Is there any question? Please let me know. কারো কোশ্চেন নেই কিছু? Okay, so let's try to solve some of the problems. So is this diagram visible to all of you?
Yes, sir.
Okay. So what we are going to do here is uh, to find out the Ixx, okay, of the shaded area. Okay. Now this of course is a composite geometry, and this for the first time we are evaluating the moments of inertia. Okay, so we'll start with the basic geometry. So what we have here is a semicircle. Okay, so let's call it A2. Okay, and this one has a radius of 30 mm. Okay, and we would like to evaluate the moment of inertia of this geometry. Remember to clearly show the differential area element. Okay, so that's what I am doing here. Okay, so imagine if this is theta, then this much is d theta. Okay, and then I'm showing two segments. So if this much is dr and up to this much is r. Okay, so r and dr, okay, that make up for this area. So the differential area element like before, okay, nothing has changed. So it is r d theta, that is this side, and then dr, that is this side. Okay, so that is the differential area, r d theta dr. Okay, and in order to get Ixx, is defined like this: integration over area y square dA, and y of course is r sine theta. Okay, now therefore we can write this thing to be double integration r squared sine square theta, then dA is r d theta dr. Okay, now this representation means that we would like to do the theta integration first, but as we have explained, because the limits of integration are independent, because this geometry in r theta coordinate system, okay, is a rectangle. So the r goes from 0 to 30, and the theta goes from 0 to pi. Okay, so this is a rectangle, which means the limits of integration are independent of one another, and we have repeatedly discussed this. So so it doesn't matter which one we do first, but since the representation is such that the theta integration is done internally, so first we will put the theta limits 0 to pi, and then the r limits, which is 0 to 30. Okay, and if we want, we can do the two integrations separately and multiply them. Okay, that will also be valid. Okay, so we can perform sine squared theta d theta over here, and r cube dr over here. Okay, so can you please calculate this and tell me what is the value? Are any of you trying?
Yes, sir.
Okay.
pi r to the power 4 by 8.
Okay, but you have the value of the r, right?
Yes, I think.
So as he said, it is going to be pi times 30 to the power 4 divided by, oh, it looks like 304. No, it's 30 to the power 4 divided by 8. Okay, is that correct?
Yes, sir.
Yes, sir.
No, this one is correct.
Hmm.
Okay, and what is the value coming out to be?
308, 3,18,000, 3,18,000.
This much?
Yes, approximately.
Okay, okay. Okay. Can others verify if this is correct? Is it is this what you are getting?
Yes, sir. This is correct.
Okay, 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 great. Okay, so this is for the circle or the semicircle. Okay, number one. Number two, let's try the triangle. Okay, so again, for the triangle, I can take the width as a function of y, w of y. Okay, and w of y for me would be, so this height is let's say y, and this height is let's say dy. Okay, and this is let's say the x-axis. This is the x-axis, and this is the y-axis, and this is my preferred differential area dA. Okay, and dA is w of y times dy, and w of y in this case should be 100 times 1 minus y by 90. Is that so? Is this correct? 100 times 1 minus y by 90. Is it correct? So if I take y equals 0, it is 100, and if I take y equals 90, it is 0. Okay, that's all I am trying to say here. Okay, and then I can do the same exercise to get the ixx. Okay, so I'm going to call it ixx2, and this one I'm calling ixx1 because I'm calling this one as a1. So if I perform the integration a y squared dA, okay, so so it is going to be 0
স্যার
to,
ডাব্লিউ অফ ওয়াইটা আরেকবার একটু বোঝাবেন?
হ্যাঁ কোনটা ডাব্লিউর এক্সপ্রেশনটা?
হ্যাঁ,
দেখো এই যে ট্রায়াঙ্গেলটা এর বেসের উইডথ কত 100,
হ্যাঁ,
আর একটা ভার্টেক্সের উইডথ কত 0, তাহলে তোমাকে
হ্যাঁ।
100 থেকে 0-তে স্কেল করতে হবে ওভার আ হাইট অফ 90 millimeter.
আচ্ছা, আচ্ছা, হ্যাঁ,
If I take
ইকুয়েশন
y
ঠিক
equals
আছে।
0 in this expression, you get 100. That means on the x-axis the width is 100, and 90 millimeters away from x-axis it is 0.
হ্যাঁ স্যার, ঠিক আছে।
বোঝা গেছে? আচ্ছা, now this is y squared, then w of y dy. That's it. Okay, so solve this one and get the ixx value for the triangle. So I got an answer which is uh, which says 6.075 into 10 to the power 5 millimeter to the power 4. Is that something you are getting? I was kind of hoping that it would be more than that.
So 10 to the
Sir,
power
same.
6
Sir,
probably.
10 to the power 6.
10 to the power 6. Okay, 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 yeah. Then it makes sense. You see, a lot of portion of the triangle is farther away from x, okay, and because of squaring the y coordinate, I was expecting a higher value. That's what I said. Yes, then it makes sense. Okay. Although the circle is quite wide, but it is closer to the x-axis, so it doesn't make as big of a contribution as the triangle or this part of the triangle. Okay, so now you know the answer. If you want to get ixx for the geometry, it is ixx1 minus ixx2, as simple as that. Okay. Okay. Uh, Now, this would be your assignment for this geometry to get the IYY values. Okay. So, for this geometry, get the IYY value. For the composite geometry. Okay. Now, let's take a challenge. Okay. Let's try this. Determine Ixx about the centroid. So for this geometry, I'm asking you to give me the centroidal area moment of inertia. Okay, so let's say the centroid would be somewhere over here. Okay, I should probably be using a different color. So let's say the centroid would be somewhere over here. So this is x prime and this is the y prime coordinate system. So I need you to first determine the value of the y bar. So coordinate of the C would be x bar y bar, but x bar, because of symmetry, is going to be 0. Determine y bar for this geometry. Now for the triangle y bar 1, for the triangle y bar 1, so we'll do this, okay, using a table. Okay, so table, as we discussed earlier, so the first one would be the serial number. Okay, so in which you have the area 1, which is the triangle, area 2, which is the semicircle. Number 2 that you would evaluate is the area. So A1 would be the area of the triangle. Okay, and the area of the triangle would be how much? It would be, can you calculate the area?
4500.
4500 millimeter squared. And what is the area of the circle, semicircle? pi by 2 times
450
r
pi.
square. Sorry,
450 pi.
450 pi, and what exactly is it?
Sorry, not 450.
I think you are correct. 450 pi. Pi by 2 times r squared.
450 pi.
And how much is it?
So 1414.
1414. Okay.
I mean 1413.7.
Okay.
Sorry, from
1414 millimeter square. Okay. Now, let us decide the coordinates of the centroid. Okay. So y bar for the triangle is very simple to get, right? It is 30.
Yes, sir.
Okay. But what about the semicircle? So you'll have to calculate that. Okay. I mean, I know by the time you appear for the class test or the semester exam, you would eventually have marked up some of the formulas. Okay. But that is not encouraged. I would wish that you would derive the expression for the centroid. Okay. So, as you again show the differential area, then the differential area is r d theta dr. Okay, and a times y bar would be this, 0 to 30, 0 to pi. Okay, r sine theta, r d theta dr. Okay, so this can be written as 0 to 30 r squared dr times 0 to pi sine theta d theta. Okay, so if you do that, that actually would give you the value of the y coordinate, sorry, the y coordinate of the centroid of the circle, semicircle. So it's going to be r cube by 3, and then y bar is r cube by 3 divided by pi by 2,
Sir, 6.36 mm.
6.36 mm. Okay, so this is the area, pi by 2 r squared. If I do that, okay, I am supposed to get twice r divided by 3 pi. Okay, is that what you are getting?
Sir,
Yes.
hello,
হ্যাঁ বলো,
hello, sir.
বলো, শোনা যাচ্ছে, হ্যাঁ শোনা যাচ্ছে।
Sir, it should, sir,
sir,
it
the
should be
integration of
ইন্টিগ্রেশন,
sir, it should be 2r cube by 3.
হ্যাঁ স্যার, ওটা তো 2 আর একটা এক্সট্রা হবে স্যার। 0 থেকে পাই সাইন থিটাটা একটা 2 আসবে তো।
4 r by 3 pi হবে।
4r by 3 pi। ওকে ওকে ওকে, ইয়েস কারেক্ট
হ্যাঁ,
কারেক্ট কারেক্ট, 0 টু পাই ইন্টিগ্রেট করলে এখানে 2 আসবে। ওকে
2 আসবে স্যার,
কারেক্ট।
ওটা তাহলে আসবে 12.7324।
12.72 আসছে।
ওকে, 4r by 3 pi, so 12.73 or 72 whatever. Okay, so
ইয়েস স্যার।
12.72 millimeter, right? uh, then we have already evaluated the ixx and iyy value, right? And what were the ixx value? What was the ixx value?
IXX 57.57 into 10 to the power 5. Oh, now that's a net
No,
triangular
6 point something was
6
it?
6.075 into 10 to the power 6.
6.075 into 10 to the power 6. Okay, and this one was 3.18 into 10 to the power 5, as some of you pointed out. Okay, okay. So now what we are going to do is, now we are going to write the formula for the total area. So A is A1 minus A2. Okay, and then evaluate that quantity. Ixx is Ixx1 minus Ixx2. Okay, so evaluate this quantity, and then the A times y bar, okay, A times y bar is A1 times y1 bar minus A2 times y2 bar. Okay, this quantity is also required, so evaluate this quantity. Okay, or in other words, you can do this and divide both sides with the total area, and that will give you the y coordinate of the total area. Okay, right now you have the y coordinate of the centroid of the triangle and y coordinate of the centroid of the semicircle. Now if we want to evaluate the y coordinate of the centroid of the total area, this is the formula. So how much is the total area? It is 450 minus 1414, so I am
So
guessing
3086.
3086. 3086.
0.28.
Okay, and how much is this quantity, y bar?
So that is 37.91 millimeter.
37.91 millimeter, correct. Okay, then okay, so basically you took out some material uh, from the region closer to the x-axis, so the centroid shifted towards upwards. So because earlier it was 30 millimeter, because you took away some material closer to the x-axis, the centroid actually went further away from x-axis. That's what it looks like. Okay, so always check that it also makes sense intuitively. Okay, and also check your math. Okay, so these problems can be confusing at times, when to subtract, when to add, or anything. Okay, now ixx, how much is the value? You said 5.57 point something or 5.7 something.
57.57 into 10 to the power 5.
57.57 I mean
हाँ
5.757
हाँ हाँ
okay,
757 into 10 to the power 6.
10 to the power 6 millimeter to the power 4. Okay, now you have all the ingredients that you require if you would like to evaluate I x prime x prime. Okay, and that is just I xx minus a times y bar squared, and this is I am talking in reference to the shaded area. Okay, everything is in reference to the shaded area. Okay, now no triangle or no semicircle is there, it's just the shaded area, for which I have the area, I have the moment of inertia about the global x-axis, and I also have the coordinate of the centroid, y coordinate of the centroid, so I can evaluate the moment of inertia about the centroidal x-axis. Okay, okay, so is there any question regarding this problem? Could everybody understand this one? So if we are clear with this one, we will move on to the next problem.
Sir, can you once, uh, can you once demonstrate how to take component for evaluating IYY for this geometry for the sector?
For this geometry, okay. Um, See,
Sector part.
yes, yes. I'm not doing the centroidal one for the global Cartesian. Okay, to get the IYY. Okay, so for example, if I would like to get the IYY 2, okay, that actually would be same same as uh, IXX2. Okay, you can check that, because you see in the end you do the moment of inertia for the quarter circle and double that up, that's it. Okay, uh, and and so if I take the quarter of a circle, okay, moment of inertia with respect to the x-axis and with respect to the y-axis, it's the same. Okay, and if you take both the sides, then it's just the double. Okay, so for the global Cartesian, not the centroidal coordinate system, so for the for you know origin at the center of the circle, this expression will be valid. Okay, now of course for centroidal coordinate system you will have to do all these sort of manipulations that we have done here. Okay, now for the triangle, now when you are using the triangle, I would suggest you do this. You take half the triangle, okay, and if you actually check that the expression that we got for the triangle, okay, for a triangle, the IXX that we got actually was one third BH cube. Okay, so where B is sorry, I made a mistake. So this is B and this of course is H. Okay, now I made a mistake in writing this expression, so it is supposed to be 1 by 12 BH cube. You can check that, this is what you are going to get for a triangle. Okay, so for example, if we substitute those values, so B is like 100, okay, and H is 30. Okay, so you take cube of 30, it becomes 27,000, and then B is 100. Okay, and divide that by 12, so this gives you 25, and this gives you how much? Um, 9,000, right? 1 by 12 BH cube.
Sir, is it H the 90 mm?
Ah, yes, yes, yes. Sorry. Yes, that's what I think is a mistake. Okay, so H cube would be this much, 729,000, and if I divide this one with 3, I'll get 243,000. Okay, and if you multiply 243 with 25, you are going to get this expression, I believe. Okay, um, so so for a triangle this would work out. Okay, eventually, I mean, whether you use that formula, I don't care, because it's a very simple formula. Okay, or you can actually derive it, I don't care. Now if I take half the triangle, okay, and consider this to be the B, okay, and then B is 90 and H right here is 50. Okay, so the IYY for 1 would be 2 times 1 by 12 into 9 into 50 cube. Okay, so once I have the moment of inertia of the triangle, the total triangle, and then moment of inertia of the total semicircle, okay, I can subtract those two and I'll get the moment of inertia for the shaded area. But of course, if you want to get it for the centroid, all those manipulations are there. Okay, and actually it would not matter, because the centroidal axis, see, y axis y prime axis is also same as the y axis. So this right here is the centroidal moments of inertia. Okay. Because this y axis actually passes through the centroid, so uh, this is actually the centroidal moment of inertia. Okay, so no issue with this one. Okay, so is that part clear? How to get the moment of inertia about y axis?
Yes, sir.
Huh?
Yes, sir.
Okay. Okay, so let's move on to the next problem. So this is the problem statement. Uh, Difference of moment of inertia for the area A about the axis, that is about axis P and about axis P prime, is 50 inch to the power 4. Determine the area. What do you think we should do for this one? So I PP, because that is the further one, it would be higher than I P prime P prime. Okay, and it says I PP minus I P prime P prime equals 50 inch to the power 4. Okay, and of course we are supposed to use the parallel axis theory. But does that mean IPP equals IP prime P prime plus A times 1 squared? Is this correct? Is that expression correct?
No, sir.
No. So what is the correct expression? So to start with, assume the axis parallel to P or P prime, okay, is P double prime that passes through the centroid. Okay, so this is not correct. This is absolutely not correct. Okay, so then you can write I PP equals I P double prime P double prime plus, and that is the lowest moment of inertia, plus A times 2 plus 1 whole square. And then you also write I P prime P prime equals I P double prime P double prime plus A times 2 squared. Okay, now if I subtract these two, okay, put a negative sign everywhere, okay, then if I subtract these two, this is what we are going to get: 50 inch to the power 4, which is the difference between these two, okay, that much, and these two will cancel out, so 0 equals A times plus A times 3 squared minus 2 squared, or in other words, A equals so 3 square minus 2 square, 9 minus 4 is actually 5. Okay, if you divide that with, then you get 10 inch squared is the area of the geometry. Okay, হ্যাঁ হরিরাম আমি ক্লাসে আছি, বলো। না না বলো না, কালকের মধ্যে করে নেবো। তুমি আজকে আছো কি এখন? আচ্ছা ঠিক আছে, আমি দেখছি এখন যদি করে নিতে পারি, কথা বলে দেখছি। ঠিক আছে। আচ্ছা, না হলেও তো তোমার চাবি কোথাও থাকবে, অফিসে টফিসে কোথাও একটা থাকবে তো। আচ্ছা ঠিক আছে, খুব ভালো ব্যাপার, থ্যাংক ইউ, কোনো অসুবিধা নেই। Okay, so is that part clear?
Yes, sir.
So
Okay.
Yes,
the
sir.
p dash p dash before that it is minus sign or just a thing.
Which one?
The last expression, sir.
In
No, sir. The
this one.
yes, sir. Yes, sir.
Okay.
Is
So
that the minus thing? Minus sign.
no, originally the
Minus
expression,
code, sir.
Acha,
originally the
acha.
expression would be this. Okay. And then what I did was I subtracted both of these equations. Okay. So once I subtract this from this, I can actually get rid of these two terms. Okay. And if I subtract these two, I'm going to get this. And if I subtract these two, I'm going to get 50 inch to the power 4. And finally, that will tell me the area is 10 inch squared. Okay.
Yes, sir.
Okay. So I think we are mostly done with properties of surface, and tomorrow onwards we will discuss about dynamics of particles. Okay, but you should try more problems, and if you find any difficulty, let me know. We can discuss further. Okay, so that would be the end of the class. Thank you for joining. Most of you didn't respond. I am not sure whether you are attending or just logged in and phased out. Okay, whatever it is, it's up to you. But anyways, I'll be uploading this video in the YouTube. Okay, thank you for joining.
Thank you, sir.
Okay,
Thank you, sir. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
thank you.